Graphing sine and cosine. So a really quick way to get the graph is to look at the points at 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then back to 0. You can use these others, but if you have an idea of what the graph looks like, you can get a very quick graph in just seconds. So let's remember that sine is, in the unit circle, is y over r. So the sine of an angle, theta, is y over r. So as I look at the unit circle, I remember that r is 1. At 0 degrees, y over r is 0 over 1 is 0. So at 0 degrees, you get 0. At pi over 2, sine, again, y over r is 1, it's 1. So pi over 2, you get 1. At pi, y over r, we get 0 over 1, we get 0 again. At 3 pi over 2, y over r is negative 1 over 1 is negative 1. And then when we get back to 2 pi, which is just 0 again, we're back to 0. So for cosine, the cosine of our angle is x over r. So r is 1, we can just look at the x value. So 0, the x value is 1. At 90, pi over 2, the x value is 0. At pi, the x value is negative 1. At 3 pi over 2, the x value is 0. And back to 2 pi is 0 again, and we're back at 1. We can then use these tables to make very, very, very quick graphs of sine and cosine. Let's take a look at the graph of y equals sine x. So I've got my table from the previous page, and I know that when x is 0, y is 0. I know that at pi over 2, the sine of pi over 2 is 1. And let's call that 1 and that negative 1. That at pi, we're back at 0. At 3 pi over 2, we're at negative 1. And at 2 pi, we're back at 0. Negative pi over 2, negative 90 degrees that we're talking about. Remember, it goes the other direction in the unit circle. That's the same thing as 3 pi over 2. Exactly. Negative 90 degrees is the same as 270 degrees. So we're right here. Negative pi, negative 180, is the same as positive 100. It's the same as pi. Negative 3 pi over 2 is negative 270 degrees. And that is the same as pi over 2. And negative 2 pi is the same thing as 2 pi. It's the same thing as 0. And so you're back to 0. And our graph looks like this. Very rough. The amplitude is, it's the half the distance between the lowest and highest value. The highest value is 1, and the lowest value is negative 1. The distance between those two is 2. Half of that is 1. The amplitude is 1. I like to think of it as how far away does this graph get from the x-axis? Like right here, the greatest distance is 1. and right here the greatest distance is 1. You're looking at that as -1, true, but the distance is still 1. So the furthest it gets from the x-axis is 1, but it's half the distance between the lowest value and the highest value in the graph. The period, these types of graphs repeat in cycles. A cycle is one complete iteration of the graph. So the period refers to how long does that take. Well, it repeats. If I start at 0, it gets back to 0, and then would start over again in a distance of 2 pi. So the period is 2 pi. And we have what's called a phase shift. This is just for future reference. There's no phase shift here. A phase shift is a fancy word for a horizontal translation. So when would we have a phase shift? Well, it's horizontal. So remember that means x is what's being affected. If I said y equal the sine of x plus pi over 2, this would be a horizontal translation or a phase shift. And just like we've done all year long, when it's horizontal, it's the inverse. So this would actually move everything negative pi over 2 to go to the left. Remember that when you plug in pi over 2, negative pi over 2 plus pi over 2. When you plug in negative pi over 2, you end up with 0. So the new location for 0 is at negative pi over 2. So everything gets moved to the left, pi over 2. That's not what we're doing here, but you'll have a few questions coming up that talk about phase shifts. Let's graph the cosine of x. So at 0 degrees, we are at 1. And let's call this 1 here and -1 here. So at 0 degrees, we're at 1. At pi over 2, we're at 0. At pi, we're at -1. At 3 pi over 2, we're back at 0. And at 2 pi, we're back at 1. Remember, 2 pi is really just 0. Now, negative pi over 2, think of the unit circle in standard position. That's really just 3 pi over 2. It's 270 degrees. Negative 90 degrees, the same thing as 270 degrees. Again, look at the unit circle and think about it. But in other words, this value here at negative pi over 2 will be the same as 3 pi over 2. Now, negative pi, negative 180 degrees, is the same as positive 180 degrees. So it's the same as pi. So that means we're down at -1. Negative 3 pi over 2 is negative 270 degrees. That's the same as pi over 2. So we're back at 0. And at -2 pi, you can see the pattern, it continues. That's the same thing as 0, the same thing as 2 pi. It's back at 1. Now what we get is a graph that looks something like this. Of course, my sketch is very rough. The amplitude is half the difference between the lowest and highest values for y. The amplitude, in other words, up at 1 is the highest value for cosine, and -1 is the lowest value of cosine. And half of the distance between those two, which is 2, between 1 and -1, the distance is 2, is 1. So the amplitude is 1. You can think of this as, think of the x-axis, the distance, the furthest distance from the x-axis you get is the amplitude. So like if you're at 0, The furthest you get away from 0 is 1. You're 1 away. And like if you're at pi, the furthest you get is -1. Again, you're 1 away. It's that distance, the furthest distance from the x-axis. But the actual definition is it's half the distance between the minimum and maximum. The period refers to how long it takes for a cycle to repeat itself. Now, a cycle is the rate, like from right here to here. It's when the thing starts to repeat again. And the period is the length. How long does it take for that to happen? So the period of both sine and cosine is 2 pi. Every 2 pi it repeats itself over and over and over. In other words, there's one cycle in the distance of 2 pi. And that can change if we mess with some of our numbers. Now there's also something called a phase shift. A phase shift is a fancy word. There's no phase shift here, but it's a fancy word for horizontal translation. So when do we get a horizontal translation or a phase shift? It's when we get something like this. Y equal the cosine of x plus pi. And you'll remember from doing polynomials and all the other things we've done, how for a horizontal transformation, it's the inverse. In other words, this would be a horizontal translation of negative pi. That would move everything to the left pi. We're going to see that, but not for right now. So phase shift is a vocabulary word you have to be aware of. Here are some problems from your assignment. First question is, determine the amplitude and period of the function shown in this graph. The amplitude is half of the distance between the lowest value and the highest value in the graph. So the distance between 4 and -4 is 8, and half of that is 4. Again, I think of the amplitude is how far from the x-axis the graph gets, up or down. The problem with thinking it that way, I suppose, is that you could have a vertical translation and move the thing up and down, so you'd have to keep that in mind. But you can always figure it out by finding how far apart the highest value and the lowest value are and taking half of that. The period is how long it takes for the graph to repeat itself. Well, you'll notice that at 0, we're at 0, the thing goes down and back up and down and back up. So the graph will begin to repeat itself when it gets to 3. The whole thing will occur again. So the period here is 3. Without graphing the function y equals 6 sine 10x, determine its amplitude and period. Leave the answer in exact form. Type pi for pi. So what you need to know is that if I write a function as y equal a sine x, the amplitude is just going to be that number in front. Remember that when I say y equals sine x, the largest value you get out of, think of the unit circle, of sine or cosine is 1, and the smallest value you get out is -1. So the distance between those two, 1 and -1, is 2, and half of that is 1. So again, the largest value you get out is 1. If I put a 6 in front, that means the largest value you get out would be 6 times 1. It would be 6. So the amplitude is 6. In general, it's just the absolute value of the number in front of the sine or cosine. The period is normally 2 pi. It takes 2 pi to complete one cycle. Now, if I put a number in front of the x, like the 10, that means there's going to be a whole lot more cycles in that same amount of time. So all it is just take the 2 pi, the normal sine and cosine period, and divide it by that number in front. Now the negative, again, wouldn't matter. Negatives, like in front of the 6 or in front of the 10, reflect things. Here then, the period would be 2 pi divided by 10, and that simplifies. We can divide those both by 2 to pi over 5. So we will get one complete cycle and a distance of pi over 5. Here's another one, this time cosine. Everything is exactly the same though. The amplitude is affected by that 3. So the largest value we get out, instead of 1 and -1, will be 3 and -3. The negative does not matter, that reflects it. So the amplitude is 3. And the period is 2 pi divided by that number in front of the x, the 2. So the period then is pi. In this example, we have a phase shift right here. This is a horizontal translation. And remember, with horizontal, it's the inverse. So the phase shift is negative pi over 5. The amplitude is again the number in front there. Ignore the negative, that's a reflection. The largest values we'll get out of this will be 4 and -4. So the amplitude is 4. The period, now there's something we have to understand here. This phase shift or horizontal translation has no effect on the number of cycles in a given distance. The 2 does. So in fact, the normal sine and cosine period is 2 pi. And the 2 here is what matters. Notice the way this is written. We can see the phase shift the way it's written. And the 2 is what will affect the number of cycles. So it's 2 pi divided by the absolute value of 2, or 2 pi divided by 2. So the period is pi. Now remember, if you get confused on this, you can always go to Desmos, click on the little toolbar and change it to radians. You can also there choose the x-axis to be labeled in units of pi. So you can count by pi over 4, pi over 2, or pi. And you can look at this on Desmos and verify your thinking. That's a good way to do it. Another example, and see how fast this goes once you start getting it down. The amplitude will be 12. The period, well, let's do the phase shift first. The phase shift is right here. This is a horizontal translation, and we know horizontal is the inverse. So the inverse of minus pi over 6 would just be pi over 6. This will move everything pi over 6 to the right. And the period is affected by this 5. The normal period is 2 pi. 2 pi divided by the absolute value of 5, or 2 pi divided by 5. So the period is 2 pi over 5. These also go very quick. There isn't much difference in this graph and the one we did earlier. The difference is the amplitude will be 4. The highest value will be positive 4, and the lowest value will be negative 4. Other than that, it's the same exact graph. We just have different units on our y-axis. So the sine of 0 was 0. The sine of 90 was 1, but that'll get multiplied by 4, so it'll be up at 4. The sine of pi radians is 0 again. The sine of 3 pi over 2 is, that's 270 degrees, is -1, but because of the 4 in front, it'll be -4. And at 2 pi, we're back to 0 again. And 5 pi over 2, this is just a repeat. This is the same thing as pi over 2. We're starting a new cycle. And then it'll be heading down. So, the one thing I did have trouble with when I tried some of these, when you go to draw it, you got to make sure you grab the right one. I noticed that I tended to grab the wrong one first. Just make sure your graph looks like it should, and you will figure it out. But we have something that looks like this. Here we have a vertical translation. This is just a normal cosine graph, but everything's going to be slid down 1. So you can basically imagine that -1 is the new location for your x-axis. So everything just slides down 1. The cosine of 0 is 1. And so normally I'd be up at 1, right, up here. But because of this -1, it's down 1. The cosine of pi over 2 is 0, but because of the -1, we're down here. The cosine of pi is a -1, and because of the -1, we're down at -2. The cosine of 3 pi over 2 is 0 again, but we're down at 1, -1, because of the -1. The cosine of 2 pi, it's the same thing as 0, so we're back to where we began. And our graph looks something like this. Again, you may have to play with this and grab the right one to make everything look right. In this example, the amplitude is 5. And the period, this right here, is really 1/2 theta or x or whatever you want to call it, and that's your variable. So it's 1/2 times x. So the period is normally 2 pi. It's 2 pi divided by b, and remember that is bx. So it's 2 pi divided by half. Well, you have to multiply by the reciprocal, so you're going to get 4 pi. So the period is 4 pi. This is stretched way out. So let's lightly sketch just the normal y equal the cosine of x. And we will then modify that to make it look like it should. So I'll do the cosine x in blue here. So the cosine of 0 was 1. Need my pen, is 1. At pi over 2, we're at 0. At pi, we're at -1. And at 2 pi, actually at 3 pi over 2, we're back to 0. And at 2 pi, we're starting all over again. We've completed one cycle. We're back to 1. So this, squished in here. This is our normal cosine graph. Let's try that again. Now we're going to stretch that out over a period of 4 pi. So, and the amplitude will be 5. So we're going to start up at 5 instead of 1. And see how we ended at 2 pi with the cosine graph? Let me change colors. We're starting at 5. So we're going to end at 4 pi for a cycle. So it'll be right up here. Now look at my little mini graph of y equal cosine x. There are 1, 2, 3, 4, and back where we begin. There are 5 there are key points, but really 4 because we're back where we began, but let's say 5 key points. And look where these are. There's a quarter of the way through. There's a halfway through. There's 3/4 of the way through. And finally we get back to where we started. So we could break this into fourths. So look at these lines here. There's 1/4 of the way. There's 1/2 of the way. There's 3/4 of the way between our 2 key points there. So look how we were at 0 at right here at pi over 2. So we're going to be 0 1/4 of the way. So that will be right there. I guess I should have maybe chosen different colors. Let's try red. All right. And at halfway through, right here, we were down at -1. And since our amplitude is 5, we'll be down at -5. So at halfway, we'll be down at -5. And 3/4 of the way, right here, we're back to 0. That's right there. And so we've got one complete cycle now graphed. And this is going to be rough because I'm drawing these by hand. But something like that is one complete cycle. So break it into fourths and just keep going. I'll be back to 0. If I go another pi units and another pi that, I'll be at -5. And another pi, I'll be back to 0. And another pi, I'll be up there at 5. Now, if all that was confusing to you, there's another way we can look at this. It's very simple, especially in this case. So if I go to the, and make a table, if I go to the x-axis and think about this, let me choose a different color here. How about this one? So if I go to pi and plug it in, notice that when I put in pi right here, it's pi over 2. So that is the pi over 2 value for cosine. When I put in 2 pi over 2 is pi. So at 2 pi, that's the pi value of cosine. When I put in 3 pi, it's 3 pi over 2. And that's the 3 pi over 2 value of cosine. So you could graph this very quickly with a table also. I was just trying to show you that the pattern exists, that these are a series of transformations, and I can look at the original graph and think about what's happening to graph this. And there's more than one way to do this. This one is a phase shift, and remember a phase shift is a horizontal transformation. The phase shift here, phase shift, is horizontal is the inverse, so this is pi over 2. Everything will get moved to the right, pi over 2. So I'm going to do a quick sketch of sine, exactly like we did earlier, and then I'm going to just move everything pi over 2 to the right. So let me graph sine quickly. So I just sketched one cycle of sine, and this is going to be exactly that graph, but I'm going to move everything pi over 2 to the right. So I'll do that in black. So 0 will go to the right, pi over 2. Up at 1, that'll go to the right, it'll go to pi. Down at -1, that'll go to the right, pi over 2, it'll go to 2 pi. And 2 pi will go to the right, pi over 2. And that will be, these are hard to read because these are so close together. 5 pi over 2, I think that is. And then I just need to repeat. So here's one cycle again. Looks like I forgot 1 pi, moved to the right, pi over 2 should be right there. So down we go. Here's one cycle. And when you graph this in Desmos, it makes it very easy because it just repeats. You just need to grab a couple of points. So play with it until you get your graph in the right position. But basically, look here. Every pi over 2, or every 2 boxes, I'm going to get a new point. So I'll be up here and down here. And here. Last one, and I know if you brave through all of this, good job. But I wanted to give you plenty of examples in case you needed it. Here is the last example, and this is another phase shift. And we know that it's horizontal transformation, and it's a translation, and it's horizontal, so it's the inverse. Therefore, our phase shift here is pi, negative pi. So this will move everything negative pi to the left. First, I'm going to very quickly sketch the cosine graph. I've noticed that they made this a little more difficult in how they labeled the axes, but we can simplify that very easily. We see pi right here, so pi over 2 is going to be halfway in between. There's pi over 2. And halfway between pi and 2 pi is 3 pi over 2. So right here is 3 pi over 2. And I'm going to ignore their units. So there's one complete cycle of y equal to cosine. And in black, I'm going to do a phase shift. I'm going to move everything pi to the left, negative pi. So 1, which is at 0, will get moved to negative pi. 0, which is at pi over 2, will get moved pi to the left. So we'll go pi over 2, and then another pi over 2. Remember, that was halfway between these two. This was negative pi over 2 right here. So this point here will get moved right here. Pi, that's an easier one. That's at -1. Pi will be moved pi to the left. It will be at -1 right here. Pi radians to the left. 3 pi over 2 will move pi to the left. It'll be at pi over 2. And 2 pi will move pi to the left. Will move right here. So we've got one complete cycle right here. So after that, we just need to repeat. Now you need to notice the pattern here. Basically, I get a key point every 1.5 boxes, which is pi over 2 units. So every 1.5 boxes, I get a key point. So right here would be a key point, 1.5. The next one will be 1.5 boxes at 2 pi. Continue the pattern, down it goes. 1.5 will be right there. 1.5. Continue the pattern, will be right there. And then we just need to repeat that. last note, I'm doing way more figuring out here than you will need to do, because you're going to choose one of these two and draw it, and once you get a couple of key points, you're done. It will automatically create the rest of it.